Uh-oh. No ticky ticky. Headlights doesn't start. Hey everyone, welcome to the Flat Thunder channel. My name's Andy, and this is my 520H Wheelhorse. Going up. Going down. Handy lift. American made. Yeah. We just lowered down the lift. This is my Handy branded motorcycle lift. Not affiliated in any way, but this is an awesome lift. I bought it for working on motorcycles, but we put the side extensions on so we can work on this tractor. I'm not afraid to admit it's been lurking around on this lift ever since April, March of last year, and it's been broken for much longer than that. So we need to take a look at this thing and see if we can't get her fixed up. We got the plow on it, and we need to get that in working order for the winter months. Let's take a little look under the hood. It's got the 20 horsepower Onan air-cooled engine. And this isn't right here. This side panel is kind of bent out at this angle. It's supposed to be supporting the console, but we have it removed because we had some wiring issues in here, and this just big mess of wires and cables needs to be addressed, and things need to change. This cover, obviously the screws were removed previously. Show you what's behind there, and this cover as well. So if you look behind those covers, you're going to see some wiring, some switches. This is a micro switch for the directional control lever. That's forward, push down, that's reverse. Get you a little better angle of it here in a minute. This is the directional control lever, or linkage here. So from here to up here, this rod with spherical bearing on the end and a joint up here is what controls the direction of the tractor. It's a hydrostatic drive. So to go into reverse, you have to push the lever straight down, which pulls this bar down. And then pull backwards, which shoves this bar backwards, moving this linkage that way. So that's reverse. And then for forward motion, you just push forward and it pulls it. Well, if you can see here, this has some non-factory tie wraps holding this control rod to this bracket on the motion control lever. These were required because this joint, it's a universal joint, allows it to pivot, would pop off because it's worn. So we need to repair this end. Over here, this is the PTO control lever. We disassembled it, not 100% correct fashion. Should have removed those bolts here and there, those 3 bolts, and this bracket would have came out. We didn't want to remove those bolts for some reason, just because they're difficult to access and it would leave the motion control lever free. So what we did, it's not quite right, we removed all the bolts to the column and bent the side panel away. The reasoning for doing that is to gain access to the wires, and also the bushings for the PTO engagement shaft are completely gone or worn out. This fuse block, I'm not for sure what we're going to do there. We need to dig into this whole mess. This fuse here was melted. I'm not for sure why. Something somewhere had to short. But we dug it out of there and replaced it with a new one. And it seems to operate okay. Before that was replaced, the ignition wouldn't come on. So as you can see, we have awesome little alligator clip jumper wires, and this is what we use to start the tractor. But at one point in time, we also had to have a second pair to keep the tractor running. Just a little fun FYI, if your ignition switch is bad or you run into problems where it's not making the correct circuit, if you take a jumper wire from the positive side of the battery and put it on the positive side of the coil, this tractor will run. I'm not for sure what this is, but if you look closely, this white wire looks kind of burnt, and I believe this is some sort of voltage regulator here. So something in here happened where this looks like it shorted out. It even looks black inside the end of the connector. See the black inside the connector, and the wire is kind of brownish in color. Something definitely not right there. So we'll investigate that on top of the other wiring issues. So if you energize this middle wire, this blue wire, this will fire or engage the starter. And that's what we've had to do for many years. Mice chewed on the wiring or helped create the short. And when that happened, this wire was dead and would no longer engage the starter. So we had to use a jumper wire from this hot side of the starter and jump it to this contact point to engage the starter to start the unit. It's been like that for many years. I like to fix this tractor so you can turn the key and it still starts. Say, them are some nice tires. How'd you get that cool flat spot? Need to fix that too. Dry rotted, sidewalls all busted out, so we're gonna need a whole new tire, and we're probably gonna tube it for both sides. So we need that times 2. Temporary testing, we reinstalled the micro switch here and plugged it back in at the motion lever. To test these, if you turn the key to the on position, if you rotate it to the start position, you'll see it will not start and the PTO lever light is engaged. That's because the micro switch, this guy here, is not made. So I'm going to put a tie wrap on this temporarily to test the starting circuit. You should be able to hear, I don't know if you'll hear it on the camera mic or not, but you should be able to hear a click when the switch is made. So that's definitely has to be made because it's as far down as it can go. Air lights are illuminating when the key is in the on position. For testing, we're going to be testing circuits, and we're going to use the resistance setting. So we're going to rotate it. This is volts DC. Down here where it says ohms, you can see it says ohms. That's resistance. But in particular, we're going to use the audible setting. So I'll show you exactly what that does here. Let's turn it to that. In that setting, we're still just checking for resistance. But if I take both test leads and I touch them, it'll read the resistance, but it'll also give you an audible alarm. Or we could switch it over to 200. This is going to be a very low resistance, and the resistance is 0.2 to 0.3 ohms between the leads. I'm going to connect one end to the wire at the starter solenoid, and then I'm going to start tracing back to try to find the wire and the rest of the wiring harness and make sure that wire is still good. On the front side of the engine of this 20 horsepower Onan, this is the starter solenoid right here. It has power coming to the unit, and then the trigger wire would go in the middle. I already removed it. It's this blue wire right here. So this is what would tell the starter to start when you turn the key to the start position. But it does not start. So we're going to probe this wire. I'm going to plug one terminal in there. We're going to go back up to the relays, and we're going to put the other terminal on the wire at the relay to make sure the wire isn't broken between here and there. Looking at the tractor from the side, if you look down at the top, this is the battery. All the relays are straight down in between the engine and the battery. Here are the relays, and it looks like there are 3 separate relays. This outer one has a blue wire coming. You gotta get behind that belt. This outer one has a blue wire going to it, the same color as the one at the starter. So I'm going to check that wire and see if this is connected to the wire at the starter. So I can just weasel it in there. I have to turn the meter back to audible. Now, I'm not for sure if you can hear it, but we are getting an alarm that's saying this blue wire is indeed the wire, or at least it's connected to the wire up at the starter solenoid. So that leads me to believe this relay right here is associated with the starting circuit. It's reading 0 resistance and the alarm's going off, and it's saying there's 0.2 of ohm resistance, basically meaning that wire up here, the starter solenoid, is the same wire that we found back here at the relay. Since that blue wire is connected and not broken in between the starter solenoid and the relay, which I believe controls the starting circuit, that relay must not be energizing properly or working properly to tell the starter to start. Now that could be all the circuitry before the relay as part of the safety, or it could be the relay itself. So now what we're going to try to do is access the relay and check all the connections to the relay. It should be grounded. It should have a positive connection. It should have a control wire, and the control wire is I believe a positively switched feed, and that positive feed should tell that relay to close, and when it closes it should supply power to the starter solenoid. So we'll try to get that relay unplugged to get it out of there and see if it has all the necessary connections. Crusty in there. Ta-da! There's some green corrosion on this terminal here, which might indicate this is our problem. So we're going to take this relay and we're going to hook it up with some alligator clips and to see if we can get it to switch. Looks like it has green corrosion coming out of it, probably from battery acid or our good old rat friends peeing on it. So we're going to just diagnose this relay here. It's a better light angle for you. You can see some of the green stuff on that tab there, maybe a little coming out the bottom of it. If this isn't glued shut, I'll pop the top off and see if we can clean the internal contacts. There's one side. Oh, sorry. There's the other side. And this is a pretty, looks to be like a pretty common relay, pretty standard issue. Here's the internals. The basics of this is in a coil, and when it's energized, it magnetizes and sucks this spring-loaded plate down. And when this plate gets sucked down, it takes this contact from here and moves it over there. So I'll clean these contacts up, and we'll get some jumper wires out, and we'll test this to make sure power switching. Usually it shows a wiring diagram on here on what's being switched and which terminal's which. And then the bottom has the terminal names. The best way for me to clean that and clean all that off there was to unplug all three of those. So we're going to clean all the connections in there, get all the grass off, spray some contact cleaner in there, clean all these connections, test this one, which I'm pretty sure is not working correctly. If it works correctly, we'll put it back together and we'll test it after we get it all back in there. I scraped all the grass off the top of that and dirty buildup. Now we're going to hit it with some contact cleaner. On these other units, which I don't think are corroded as bad as the first one, let's take a little piece of sandpaper or emery cloth, and I'm going to clean. That one had a little corrosion on it. I'm going to clean all the contacts, hit it with some contact cleaner, and reinstall them. If you look at this cover, we have 85, 86, 87, 87A, and 30. These are the connections inside the relay. And if you look at the bottom of the cover next to the terminals, there's also the numbers. There's it. I don't know if you can read it, but up here is 87, 87A, there's 30, 85, and 86. I'm by no means an expert on wiring, but if you look at this, you see 85 on this end, 88 over here, and this thing in the middle, I'm not sure if you can see with the lighting, but this thing in the middle I believe represents the coil that makes the switch. So 85 and 88, 5 and 88, these two outside connections. So if that's right, when I put a ground and a positive to those two, this switch should close. So I have my old friend the alligator clip here. So that's a positive on that terminal. And then I'm going to touch a ground to this other terminal, and you should see the switch move and hear it click. So this relay is definitely working. Now, the question is, are the terminals up on the tractor providing the correct signal to make this relay work? So looking at this cover again, if you look at the top, it says 30 terminal is always connected to 87A, but then on the switch it goes to 87. So I'm going to test the terminals with the multimeter to see when it's not closed, is 30 connected to 87A, and when the switch is energized, is 30 connected to 87. So we'll get the ohm meter set up and we'll test that. It should be connected to this normally when it's not energized, and then switch to this one when it is energized. So that's good. Let's energize it and check to see if it switches to this outer one. Mechanically we can see it moving, but we don't know that this is making connection. Now if you're going to use alligator clips, this one's a little bit on the larger side, but if you keep with thinner gauge wires, It will help prevent shorting. That way it'll just melt the wire if you have anything massively wrong. This guy's little, so it'll just burn this wire up if you have a massive problem. Keep your fingers out of the connection. There, you can hear it clicked. So it's switched. It's no longer from here to here. If I remove this, open the circuit, now it's back on the middle. So this relay is doing everything it's supposed to. All we have to do is make sure the connections are right up on the engine. Let's put this all back together. We'll hit all the relays themselves with contact cleaner and we'll test it out. Okay, we have all the relays back installed after cleaning them, and we have our multimeter set up for audible alarm on resistance, connected as it was previously at the starter solenoid, but this time we connected the other lead to the positive side of the battery, and we're going to try the key. And it's still not making connection. Well, you missed the smoke show. Didn't have it on. But remember what I said about thin wire alligator clips? Accidentally bumped this one to the frame. She's melted. We got a little smoke show. Of course, as it melted, it touched the grounded out in more spots. So this wire is that shot. And the good news is, it didn't catch on fire or blow anything up because it just melted the wire. I think I found one of the major problems. This is the ignition switch, and the plug on it was kind of angled a little bit. I mean, it was still on, but it was hanging sideways a little bit, and all this corrosion is inside of here. So I think we had a bad connection here that was contributing to one of the problems on the tractor. To have a nylon bristle brush, you know, that dirt and grass and oil residue out of there. Okay, that's way better. So as long as there isn't a ton of corrosion inside this housing on the actual contacts inside there for the switch, this should work a lot better. And they're all kind of bent up at an angle. It's because of the way it fits in there. So it's like this contact isn't getting a good grip on the terminal. So the little trick I'm going to try to do is I'm going to try to bend this just a little bit so it'll apply pressure on there, and I'm also going to try to straighten all these a little bit because I assume they had to be straight at one point in time. They just got bent over the years. That looks a little better. I think I'm going to try to get this pink, I think that pink wire there, I think that's the start circuit. I'm going to try to get this out of the connector here and crimp it a little bit so it's tighter on the actual spade. I have my terminal release tool. It has a special end that you stick down inside to release these connectors. Trick is doing it without breaking it. There we go. It's a nice tight fit. Alright. Let's get him back in there. Since we're in here, I'm going to pop the other ones out and snug those up too. Okay, with the ignition module or the ignition switch out of the console, we'll try starting. After I put it back in the console, it doesn't start. We just get a cool little click. What is that? I don't understand. It's done that 2 times now. Take it out, not here. Works fine. Put it back in. Doesn't work. So I don't know if the switch itself is grounding inside there or if it's not passing enough current to make the switch. But we're going to use our test light here and we're going to probe the back of it and see if all the correct connections are being made. So we have our test light hooked up to ground. Key is off. We're going to see which ones are hot. Make sure this works. Yep. So that one's not. Brown. Oh, this key off. Brown. Nothing. Got the orange. Nothing. Then we got the red beneath it, which is hot. Then we have the get in there. Pink, which is nothing. This other one's empty. So now we'll do the same thing except with the key on. We'll put this in red marker. This is in the run position. So the orange is hot. Pink is hot. And the brown is still nothing. So we still have it in the brown. Let's put it to the start. And the brown circuit is energized only on start. So that makes that the starting. Well, she tried to do it. Don't understand it. Okay, I took the ignition switch back out of the console again. Obviously plugged it back in out here on the side. Let's give it a go and see what happens. Nothing. I'm going to locate all the grounds on this and make sure they're cleaned and reinstall them, because this just doesn't make any sense. 1 minute it works, 1 minute it doesn't. Okay everyone, I don't know where we left off in the other videos, but I did do some work on this offline just as I was out here because it was really frustrating me. And one of them was this ground in here directly beside the battery. I cleaned that up and replaced that ground. That didn't really help anything. I mean, it didn't hurt anything, but it didn't solve the problem. One of the other things that I checked is I was checking this fuse right here, this 15 amp fuse. And when I was checking it, I checked for continuity with the voltmeter just across the fuse. And then I even checked for continuity on the terminals beneath. And everything was good. This was making good contact. But it still wouldn't work. So what I did is I took the blades and bent them slightly so they're slightly misaligned to give it a better contact. And reinstalled the fuse. Tried it again. And it worked. It blew my mind. This fuse was damaged previously. It was melted, and I thought it was melted because, you know, moisture and dirt got in there and it just direct shorted it, and or another poor connection caused it to short and melt out or just draw too much load, which doesn't make sense because a fuse shouldn't melt, it should just blow the fuse. Well, what I think happened in this case is this fuse, because it stopped working a long time ago, the start circuit, this fuse had a poor connection in there, and that poor connection caused it to heat up and melt the plastic inside there. So I think that was the problem all along. I don't think it was anything to do with the relays we played with. I don't really think it has anything to do with the wires on the regulator that we changed, but it was good to change them. And I don't think it was anything to do with the ignition switch, even though it was really crusty. So just to recap what we've done, we took all the relays out, we cleaned those, put those back together, removed the ignition switch, cleaned all the goo off of it, put that back together, replaced a bad connection, which I think is just a poor design on this voltage regulator, where that bare splice where it ties in the gray wire with the white wire could very easily short out because it wasn't insulated. Replace that with a fully insulated connector with a better connection. That's a solder joint. And on this, all we did was bend the fuse so it gave us more friction and a better contact in there. So that's the fix. Let's put it all back together and see if we can't get her off of this rack. Hey everyone. So we did it. We fixed the tractor starting circuit and everything works with the safeties in place as it should and as it was originally intended. Unfortunately, we did not get the tractor off of the lift as we originally intended. We had a few other items that we needed to repair. They are already repaired. I already have video footage of them being repaired, with the exception of the front tires. The front tires are on back order or delayed on shipment. But the motion control lever, I repaired that. That's all back together. I reinstalled all the micro switches and reassembled all the covers, and the entire tractor is in one piece again. So, alright. But this video is getting really long. We're sitting at just over 34 minutes, and I didn't want to overwhelm you, and I wanted to make sure I left in all the diagnostic wiring information, so you know, someone else that's troubled or, you know, working on a situation that's similar to mine with their 520, they can take this and they can help. It can help them diagnose their problems. My original plan was to just cut all the safety circuits out, but I wanted to make it safe, so the wife and the kids could use it without having to be smarter than the tractor. So no one needs to get run over by the tractor or lose their feet or fingers. So be safe, everybody. Try to keep your safeties on your tractor, and if you don't have your safeties on your tractor, never get off the tractor while it's running, and definitely don't leave the PTO on and get off of the tractor. Thanks for watching, everyone. I hope this was helpful to you. If you have any questions for me you think I can help you answer, don't be afraid to write those in that section below. Don't forget to give me a thumbs up, and don't forget to hit that subscribe button over there. Your likes, your questions, and your thumbs up helps the channel out a lot, and I really appreciate that. Take care, everyone.